back with some more application problems from Chapter 6. So in this case, we've got a couple of questions that are just asking for unknown numbers. And I think that solving for these is actually pretty simple. So we'll just construct the equations, and then from the equations, I'll leave it as an exercise for you to solve them. So we'll start with this first one, number 4 here. So number 4 asks, the problem or the product of two consecutive numbers is 3,306. What are the numbers? So we don't know what these numbers are, so we're going to let x represent the first number. The other one is related to this number in some way, so we probably won't need a variable for it, but we'll check. Okay, so if x is the first number, then the next number would be one bigger. So the second number is going to be x plus 1. If it said another consecutive number, that'd be x plus 2, x plus 3, and so on. So the sum of two consecutive ones, so let's just pick two of them. There's 2. Or not the sum, but the product. So the product's going to be x times x plus 1, product meaning the answer to multiplication, is equal to 3,306. And so we've mentioned this before, you have to have things in this form in order to solve them. So the quadratics need to be in this form so that you can either factor them or use the quadratic formula. So in this case, we're just going to expand into the bracket. So we've got x squared plus x, and then I'm going to subtract this other number here from both sides. So minus 3,306 equals 0. Now this is factorable. So it depends on your comfort level with factoring whether this looks factorable to you. So what I would do first is I would look at what the square root of this is. And the reason why I'm looking for that is we're looking for two numbers that multiply together to give you minus 3,306 and add together to give you plus 1. Well, since it multiplies together to give you a negative, you know one of them is going to be positive and the other one's going to be negative. Okay, so one's going to be positive, the other one's going to be negative, and those are going to be your two numbers. So when you add those together, it's going to be like subtraction. And that means that this number here is the difference between the two numbers. And two numbers that are only different by 1 are very close to being the same number. And if they were the same number, they would be the square root. So taking the square root of that number would probably get you somewhere. So we could try that. So I'll bring up a calculator. And we'll take the square root of 3,306. Okay, gives us 57. Okay, now, so 57.4978 blah, 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 blah goes into 3,306. Now, that's not the number we want to use because we want to actually get a number that divides evenly into it. So 3,306 divided by, let's try close to that number, 57. There you go, 57. And that gives us 58 as the other number. Okay, so if we go back here for a second and we say, okay, so the numbers are going to be 57 and 58, and we want it to be plus 1, so it's going to look like that. So now we can factor this. So you get x minus 57 times x plus 58 equals 0. So x is equal to minus 58, or x is equal to plus 57. Okay, that comes from doing the two factors. So x minus 57 equals 0, or x plus 58 equals 0. Okay, so throw out the negative number because we're really looking for two positive. It doesn't say that, but that's normally what the questions imply. So the first number is going to be 57. The second number will be 58 because we're looking for two numbers that are consecutive. So 57 and 58 are the two numbers. Now, if you're not particularly intuitive when it comes to finding these two numbers, then chances are that factoring was really difficult, and you may have found my logic for finding those two numbers here rather difficult. So if that's the case, there's no problem really. You just take this expression, you recognize that A equals 1, B equals 1, and C equals minus 3,306, and you plug those into the quadratic formula. So x is equal to minus b plus or minus the square root b squared minus 4ac all over 2a. And so you just plug a, b, and c in there, and you'll get your two answers. One of them will end up being 57. The other one will end up being minus 58. Okay? So no problem at all if that happens. If you can't factor that easily, then you would just use the quadratic formula. Okay, let's try number 5 as well. Okay, so we're looking for, in number 5, two numbers that are consecutive, okay, that have a product of 328. But it's not just consecutive numbers, it's consecutive odd integers. Okay, so if 3 is an odd integer, 5, 7, 9, and so on, then notice that they're 2 apart. Okay? Because they're 2 apart, then we know that if one of them is x, so let's let x represent the first number, first odd number, then we have x, and then x plus 2, x plus 4, x plus 6, and so on will give us the next set, or a set of odd numbers. So let's just write these out. So we have x times x plus 2 is going to be equal to 323. Okay, so x times x times 2 gives us x squared plus 2x. I'm going to subtract this at the same time. Subtract 323 equals 0. And once again, they're pretty close, right? So you could again take the square root of this and then factor it. And since we assume this has an answer, that we're going to get integers, it has to be factorable. So you can do that and see if you can find the set. Or my instinct here might be just to go right to the quadratic formula. So minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so you take that and plug it in there and get your two answers. So I'll leave that as an exercise for you.